Hello students, welcome to section 15. In this section, we'll be continuing with our topic, nature of the roots of a quadratic equation. So here we have roots x, 2 roots x minus b plus minus under root b square minus 4ac divided by 2a. Now the reason I say 2 roots is because one of the value is going to be minus b plus under root b square minus 4ac divided by 2a, and the other value is going to be x is equals to minus b minus under root b square minus 4ac divided by 2a. Now we're going to focus on our b square minus 4ac, as we learned that we do not know what the under root of a negative number is. So this means that any negative number inside an under root will not give me a real number. So this is not a real number, and therefore we move to our definition of the discriminant. Discriminant is denoted as delta. This is equals to b square minus 4ac. So case number 1, b square minus 4ac is greater than 0. That means roots are real and they are unequal, or you can say roots are real and distinct. Both the terms have the same meaning. Our second case is b square minus 4ac is equals to 0. This gives me roots are real and equal. That means both the roots are going to be equal. And my third case, when b square minus 4ac is less than 0, then I'll have no real roots, as the square root of a negative number does not yield a real root. So now we'll move on to some solved examples from our textbook. So this is from page number 45. This is example number 2. The question is 2x square minus 5x plus 7 is equals to 0. Always, whenever we start solving nature of roots question, whenever we are trying to get a solution for nature of the roots question, we have to compare any equation to our standard form of a quadratic equation. So here I have ax square plus bx plus c is equals to 0. This gives me a is equals to 2, b is equals to minus 5, and c is equals to plus 7. So now delta is equals to b square minus 4ac. So b is minus 5. This value is minus 5. Minus 5. So minus 5 whole square minus 4 into 2 into 7. So this becomes 25 minus 4 into 2 is 8. 8 into 7. So this is equals to 25. 25 minus 8 times 7 is 56. This value is minus 31. So now that means delta is equals to negative, which implies roots are unreal, and therefore the quadratic equation will have no solution. Now moving on to our example number sub question 2 from the same example. The previous example was sub question 1. This is sub question 2. We have x square plus 2x minus 9 is equals to 0. Now we have to straight away compare with standard form. That means a is equals to 1, b is equals to 2, and c is equals to minus 9. So delta is equals to b square minus 4ac, which is equals to 2 square minus 4 into 1 into minus 9. So here I'll have 4 minus 4 into minus 9 is plus 36. So this is 40. 4 into 1 is 4. So therefore, I did not multiply it. In a step, I just directly multiplied all the three numbers. That means delta here is greater than 0, or delta is equals to positive. This means that the roots are real and distinct. Now, before we move on to the next example, I want to make a very important concept clear. If delta is equals to positive, that means delta is at least plus 0.0001. If delta is equals to 0, this does not mean that delta is positive. Most of you might have this doubt. 0 means there is no value. 0 is not a positive number. 0 means that there is no value. For example, I have 0 oranges. That means I do not have oranges at all in my hand. Or you can take any example. I do not have chocolates, or I have 0 chocolates. Both the terms or both the sentences have the same meaning, and both the sentence in practical knowledge have the same concept. So 0 is not a positive number. It has no value. So if delta is equals to positive, that means it is absolutely in all cases greater than 0. Now, once we have cleared this, we'll be moving on to our next example, which is example number 3. So here I have root 3x square plus 2 root 3x plus root 3 is equals to 0. So a is equals to under root 3, b is equals to 2 under root 3, and c is equals to under root 3. So delta is equals to b square minus 4ac 2 under root 3 whole square minus 4 into under root 3 into under root 3. Now this is 2 square into under root 3 square. What I did is I just opened the bracket and took the square sign inside the bracket. 4 into under root 3 times under root 3 is 3. So this is equals to 2 square is 4 and under root 3 square is 3. This is my 4 into 3 minus 4 into 3. This value is equals to 0. That means delta is equals to 0, which implies roots are real and unequal. Or rather, roots are real and equal, sorry. Because we have delta 0, that means roots are real and equal. Now, once we have done this, we'll be moving on to the relation between roots of a quadratic equation and their coefficients. So, as we know that x is equals to minus b plus under root b square minus 4ac divided by 2a, and, or you can write or x is equals to minus b minus under root b square minus 4ac divided by 2a. Now, as we can see, we have two roots. That means, so therefore, one of the roots is called as alpha and the other root is called as beta. Now, there is no certain rule that you have to call this particular value as alpha or this particular value as beta. You can call either of them as you wish. You can, if somebody wants, you can call this as alpha, you can call this as beta. There is no such rule in which root has to be called as alpha and which root has to be called as beta. So now we are going to see the relation between alpha, beta and the coefficients in a quadratic equation. The coefficients meaning that we have to find the relation between alpha comma beta and a comma b comma c. That means we are trying to interlink these these set of terms. So let's try to do that. So let's first initially add alpha and beta. In my case, I'm going to be assuming that alpha is equals to minus b plus under root b square minus 4ac divided by 2a, and beta is equals to minus b minus under root b square minus 4ac divided by 2a. So this is minus b plus under root b square minus 4ac divided by 2a, and this is plus sign in the middle. This is my alpha value. This is alpha, and here I have minus b minus under root b square minus 4ac divided by 2a. This is my beta value. Now this alpha and beta is just written as reference. You do not need to write this in your copies or whenever you try to solve a question. This is just for reference so that it is easy for all of you to understand. So now what will happen once I open the bracket? We can see that I have a common denominator for both the terms inside the brackets. So all I have to do is add the terms that are in the numerator. So here I have 2a common, here I have 2a common, and minus b plus under root b square minus 4ac plus, or now plus into minus is minus, so I'll be directly writing the minus sign. This is minus b minus under root b square minus 4ac. Now as we can see, this term is plus and this term is minus. So all we have to do is cancel both these terms. This cancels with this, and I am left with minus b divided by 2a, or minus 2b divided by 2a. Alpha plus beta is equals to minus 2b divided by 2a, as we have one minus b here and the other minus b here. So I'll be cancelling the value of 2. This implies that alpha plus beta is equals to minus b divided by a. So this is the first relation that we can find between alpha, beta, and coefficients of a quadratic equation. Now moving on to the next relation, we'll be trying to multiply alpha and beta. So alpha into beta is equals to minus b plus under root b square minus 4ac divided by 2a into minus b minus under root b square minus 4ac divided by 2a. Now as we can see that this equation is in the form of a, like this particular value is in the form of a plus b into a minus b, or for our sakes, for all of you, so that just so this is easy for you to understand, I'm going to use capital letters. Here I have capital A plus b into capital A minus b, which is equals to a square minus b square. Now in this case, the denominator has to be multiplied and has to be excluded from the numerator values. So all I have to do is multiply the numerator, as both of them are in the form of a plus b and a minus b. So here I get minus b whole square minus under root b square minus 4ac whole square divided by 2a whole square, as 2a times 2a becomes 2a square. So once I open the bracket, here I get minus b square is b square minus, now under root b square minus 4ac square becomes b square minus 4ac, as the square and the under root cancels out, and here in the denominator I have 4a square. So now once I open the bracket, I'll have b square minus b square minus minus is plus, so this becomes plus 4ac divided by 4a. So Here I have alpha beta is equals to b square minus b square plus 4ac divided by 2a. Now b square minus b square cancels out. I am left with 4ac. This value is 4a square. This is not 2a. This is 4a square. So I am left with alpha beta is equals to 4ac divided by 4a into a. The reason I have written 4a square as 4a into a is because all I want to do is cancel 1a and the other a in the denominator. So I am left with alpha beta is equals to c divided by a. So therefore alpha plus beta is equals to minus b by a, and alpha into beta is equals to c by a. Now once we move on to our solved examples and practice set, there will be term. So there will be some terms that we need to be accustomed to. So as we have learned that alpha and beta are the two roots of a given quadratic equation. That means this value is sum of roots, as alpha and beta are two different roots, and this value, the second value, is product of roots. So therefore sum of roots is equals to minus b by a, and product of roots is equals to c by a. We'll stop in this section. We'll be moving on to our solved examples for the relation between roots of a quadratic equation and coefficients, and we'll be moving on to practice set 2.5. This section will end now. Thank you.